Question number 16 is a point object is placed at the distance of 40 centimeter from a convex mirror of focal length 40 centimeter. The image will form at number 1 is infinity, number 2 is the focus, third between center and focus, last between focus and the pole. It is a convex mirror and we take like this one. This is your convex mirror and this is the focus, this is the pole, and what is given that object is placed at 40 centimeter. Here is your object and its focal length f is how much? 40 centimeter given. To locate the image we use the mirror equation that 1 by v plus 1 by u is equal to 1 by f. The ray will go like this and from the pole u will be negative, so 1 by v 1 upon minus 40, it's a convex and this would be plus 40. So 1 by v is equal to 1 by 40 plus 1 by 40, this is equal to 2 upon 40, or v is equal to 20 centimeters, coming positive, so it's on the right. Your option is at infinity no, focus no, between center and the focus, between focus and the pole, yes, it is between focus and the pole. So your answer to this question is option number 4. And let's move to the next problem. Now the question number 17 reads, figure shows 3 transparent medium of refractive indexes mu1, mu2 and mu3. A point object O is placed in the medium of refractive index mu2. If the entire medium on the right side of the spherical surface has the refractive index mu1, the image is formed at I1. If the entire medium on the right of the spherical surface is mu3, then the image is formed at I2. Now, in the situation shown above, the image forms between I1 and I2. The image forms left to I1. The image forms right to I2. Image will form one at I1 and other at I2. Now, dear students, we are not changing the radii of curvature of both the surfaces, but the image formation, you know that this is the formula. In the both the cases R is same, but in the upper part, this refractive index is different than this one. So for this object, whenever you search the image, let's say in this case, after the refraction, the image is formed at this one. Originally, it was also formed at this point. And likewise from here, this image will be formed in this medium. If mu3 is more than mu2, so then it will be closer, otherwise it can be at far distance. This is the image. Originally, when it was complete with the refractive index of mu3, the image was this one. So in part, in upper and lower, the different refractive indexes, the two images will be formed, one at I1 and other at I2. Therefore, the answer to this question is option number 4. Question number 18. The image of an extended object placed perpendicular to the principal axis of mirror will be erect if the object and image both are real, if the object and the image both are virtual, one of the object and the image is real and one is virtual, both 1 and 2. Now, dear students, you know that m was equal to minus v by u, and that was equal to the height of the image to the height of object. Now, you want that image should be erect, so m should be positive. Now, for the m to be the positive, either both are positive, or if it is negative, this should also be negative. That means that if the image is erect, then the object and image should be one real and one virtual. The answer to this question is option number 3. Question number 19 says, two thin lenses of power P1 and P2 are in contact and coaxially. the focal length of the combination. These are four options, and we know that the focal length is reciprocal of the power. In this case, when two lenses are kept in contact, then the total power become equal to P1 plus P2. Therefore, the combined focal length F will be equal to 1 upon P, which is equal to 1 upon P1 plus P2. And look at the options. The fourth option is the focal length is 1 upon P1 plus P2. So therefore, answer to this question is option number 4. Now let's go to the question number 20th. A converging beam of light rays is incident on a thin lens. After passing through the lens, the rays intersect at 0.20 cm from the lens on the opposite side. If the lens is removed, the point where the rays intersect moves 10 cm closer, the focal length of the lens. Now dear students, somewhere we are keeping lens here and the rays were converging. As the rays was converging, then from here the image formed is at 20 cm. What he says that if I remove this lens, then these rays converge to 10 cm only, because it shifts 10 cm toward the lens. But dear student, this ray has been diverging, and for the lens, the formula 1 by V minus 1 by U is equal to 1 by F. If we want to calculate what is U, the object will be the virtual, so your U will be equal to 10 cm. And where is the image formed? V is equal to 20 cm. So I fill up here 1 by 20 minus 1 by 10 is equal to 1 by F. So take LCM 20 and this become 1 minus 2 is equal to 1 by F. So F come to be minus 20. If it is minus 20, answer is 2 to this question.